All right, welcome ladies and gentlemen. This is video number 4 in our Liquids and Solutions unit. You're going to need your notes open to page 25. You might also need a calculator and a reference table for this, because in this video we're going to be talking about calculations that we can do with liquids and solutions, specifically in terms of concentration and something new called molarity. This is our big unit for concentration. So first up, concentration. What do I mean? I don't mean thinking really hard. That is not what we mean when we're in chemistry class when we say concentration. We mean instead a measure of how much solute is dissolved in a solvent, specifically numbers, right? What is the concentration of the salt in the water? Exactly how much salt is dissolved in that water? And we have some general terms when we talk about concentration, i.e. concentrated and dilute. Concentrated is just a general term that simply means that you have a lot of solute dissolved in your solvent. And dilute means that you don't have a lot of solute dissolved in your solvent. If you think about a dilute solution of something that you drink, like a diluted fruit drink, it's going to taste really, really watery, meaning that there is not a lot of solute dissolved in it. But if you have a very concentrated fruit drink, there's lots of stuff dissolved in it. It's going to taste like really sweet and really fruity because you've got lots of solute there. But these are very, very general terms, and we don't like general terms in science. We like things that are specific. So our big useful unit of measure, which allows us to do so many things in chemistry, is the mole. So our unit of concentration that we use the most in chemistry involves this. It involves the mole. And what is our unit of concentration in chemistry? It is called molarity. It's called molarity. This is the unit for molarity. If we need to have a unit, it's a capital M. It doesn't have to be a capital M. If it's a lowercase m, it's not molarity. And molarity is quite simply the number of moles of solute. So number of moles, are moles, dissolved in 1 liter of solution total. And therefore, to calculate it, it is simply this formula right here. Molarity is your moles of solute divided by your liters of solution. And this is a formula. I like to call it the definition of molarity, but it's a formula. You can use it like a formula. And this is on your reference table. This is on reference table T. If you have a look at reference table T at the back of your reference table, you'll notice in the concentration section, right, we got molarity, moles of solute divided by liters of solution. Big thing when using molarity, though, volume has to be in liters. It has to be. That is the definition of molarity. Molarity is defined as moles of solute divided by liters of solution. If you cannot divide moles by milliliters or anything else, you have to convert your volume into liters first if you're looking for molarity. And if you think about it, how often have I said to you, go out and measure out, 0.72 liters of water this year? Never. It's always been, measure out 50 milliliters of water, or 5 milliliters of solution, or 100 milliliters of this other solution. It's always in terms of milliliters, so it's much more likely you're going to get volume in terms of ml, and you're going to have to convert it first. Now remember, there are 1,000 milliliters in 1 liter. So if you're given milliliters, you're going to be dividing your milliliters by 1,000 to turn it into liters. And we're going to see that as an example. So first up, sample problem. What is the molarity of a solution that contains 0.70 moles of NaCl in 250 milliliters of solution? So molarity, moles of solute over liters of solution. And what is the problem asking for? What is it giving us? What is the molarity? So that means that molarity is our unknown. Again, capital M is molarity. What have they given us? Contains 0.70 moles of NaCl. So that's our moles right there for the top portion. And they gave us 250 milliliters of solution. So that's our volume. But our volume has to be in liters. They gave us mils, we need liters, so we have to convert that. And I'm going to show you this with the T-chart because realistically this is just a T-chart. So I want to convert milliliters to liters, which means I'm starting with the 250 ml in the top left-hand corner. There are 1,000 milliliters in 1 liter. So the milliliters will cancel out, and notice this is just the dividing by. 250 milliliters divided by 1,000 milliliters, I have 0.250 liters. Having done that, now I can plug this value into the molarity equation and solve for molarity. So molarity, in this case, is going to be equal to the 0.70 moles of your solute divided by the 0.250 liters of solution, and then it's just dividing them, and I get a molarity of 2.8. Capital M is the unit for molarity, and the way I would pronounce that is 2.8 molar. This is a 2.8 molar solution of sodium chloride. Next up, how many moles are in 2.00 liters of a 2.5 molar, that's how we read the capital M, 2.5 molar solution of lithium chloride? Molarity is moles over liters. Analyze the problem. How many moles? That means that moles are unknown. That's what we're going to be solving for. That's our X. Are in 2 liters. They gave us 2 liters. What's that? That's volume, which we want. It's in the correct unit too, right? We need liters and we have it in liters, so we're good. Of a 2.5 molar, what's that? That's concentration. Specifically, that's molarity, and they've given that to us, a solution of LiCl. So we have this value, we have this value, and we're looking for that value. So we can simply plug in and solve. So 2.5 molar is equal to X moles over 2.00 liters. You're essentially cross-multiplying here. You can put the 2.5 molar over 1. That way you can solve that way. And when you do solve, you get 5.0 moles. X is equal to 5.0 moles. We have one more unit for concentration, and that's called parts per million. You'll notice that that is on your reference table on table T, all the way on the back. Parts per million is almost exactly like percent composition. How do you find percent of anything? It's part over whole times 100, right? We've been doing that for a while. Part over whole. Parts per million is also very, very similar. It's essentially part over whole. The equation here, mass of solute over mass of solution. Well, that's the part, and the solution, that's the whole thing, right? Because the solute is part of the solution. It's only one part, though. So it's like part over whole, except instead of multiplying it times 100 like you do with percent, now we're multiplying it times 1,000,000. And that is quite literally the only difference. That is the only distinction. ppm is the unit for parts per million. It's simply an abbreviation for parts per million. But again, this is just part over whole times 1,000,000 for parts per million instead of times 100 for percent composition. So example problem, what's the concentration in parts per million? So that's what we're looking for. That's our unknown. Of a solution with a mass of 1,225 grams that contains 25 grams of NaCl. Well, pulling apart the numbers they gave us, a solution with a mass of 1,225, that's the whole, right? That's the whole sucker. That's the mass of the solution. That's the whole thing that contains 25 grams of NaCl. That's the part. That's the solute. So we're looking for parts per million. The mass of the solute is 25 grams. The mass of the solution is 1,225 grams. And then we simply need to multiply, when we do that once, after we've done that division, multiply by 1,000,000. So simply 25 divided by 1,225 times 1,000,000. And we get to 20,408, let's say ppm for parts per million, and that's the concentration in parts per million. And that's it. So we'll be practicing some with molarity and parts per million. Make sure we feel really comfortable doing these calculations.